welcome to my channel. Today's video is of limits and derivatives part 5. So make sure that you have watched part 1 to part 4. Today we are going to study derivatives. It's very important. It has wide range of applications in several fields. So here derivatives or differentiation you will study in 12th standard differentiation. Okay. So here derivatives, it is nothing but rate of change. Okay. See, for example, a car is traveling from A to B. A car is traveling from A to B. Usually we calculate the average speed of the car, right? Okay. But here at a particular point, okay, at a particular point, what is the speed or what is the speed of a car? Or at a particular time, for example, at a t is equal to 3 seconds. So what is the speed of the car? See, using derivatives, we will find it. Okay. Another example, see, as I said, it's a rate of change. Here, a rectangle. Okay. Here, its side is increasing by 1 centimeter per second. Okay, that is second by second the area will be increased, right? See, one side is increasing means its area will be increased. So second by second its area will be increased. So here, see, what is the change of area when the side is changed? Okay, see here, first here this, suppose it is 3 centimeter. Okay, next after 1 second its side will be increased by 1 centimeter, right? That is next after 1 second it will be 4 centimeter. Okay, so its area will be changed, right? Its area will be increased, right? So here, so what is the rate of change? Means what is the change of area when side is changed? Okay, that is the rate of change. So here, let us define derivatives. For that, let us take a function, a real valued function f of x. So let f of x be a real valued function. Then derivative of f of x, that is denoted by f dash of x, that is equal to f of x plus delta x minus f of x divided by delta x. See here, limit is there. Limit delta x tends to 0. Okay, so it is the definition of the derivative of f of x. So here delta x is nothing but it is the change. Okay, delta x is the change of x. Okay, so here f dash of x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. See, if you directly substitute delta x is equal to 0, you will get 0 by 0 form, right? But here when it tends to delta x, so what is the value of that? When this value tends to which one? That is the derivative. Okay, rate of change. One more example. See here, slope. You should understand slope. We have already studied what's a slope. Slope of a line, right? See here, slope of a line is also a derivative. That is a rate of change. See, in xy plane. See, suppose it's a slope. Okay, we know that slope is nothing but steepness of a line, right? So here also happening the same thing, that is rate of change. Okay, when x changes, what is the change in y? See, when x changes, see here y increased, okay, here x increased, right? So here when x changes, what is the, here x changed, right? See, from here to here. Here also y changed, right? So what is the change of y? Okay, we denote it as, see, d or delta. Okay, delta change. Okay, change of y, change of x over change of x. That means, see, when x changes, what is the change in y? Okay, when x changes, what is the change in y? That is the rate of change. So remember, slope of a line is also the derivative. Okay, it is also a definition of derivative. So here remember this one, f dash of x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. So here delta x is the change of x. Okay. So what is the derivative of f of x? Okay, derivative of f of x at x is equal to a. Okay, that is we denote it as f dash of a. Just to substitute x is equal to a. That is f dash of a, okay, derivative of f of x at x is equal to a, that is f dash of a, is equal to limit delta x, or we can write it as h. Okay, delta x is equal to h. H tends to 0, f of a plus h minus f of a divided by h. Okay, so it is also a definition, that is f dash of a is equal to, that means derivative of f of x at a point, a particular point. Okay, that is x is equal to a. So derivative of f of x at x is equal to a is f dash of a, that is equal to limit h tends to 0, when h is approaching to 0. So what is this approach to? Okay, so here f of a plus h minus f of a divided by h. So remember, limit h tends to 0, f of a plus h minus f of a divided by h. Okay, now let us go through this question. Find the derivative of sin x at x is equal to 0. See here, derivative of a function, that is trigonometric function sin x at x is equal to 0 at a particular point is given. Okay, here our function f of x is nothing but sin x, right? So let us find f dash of 0. That is, here we have to find the derivative of sin x at x is equal to 0, or we can write f dash of x, or at x is equal to 0, that means f dash of 0. Okay, that is equal to, see what is our formula? Limit h tends to 0, f of a plus h minus f of a divided by h, right? So here f of a is 0, right? That point is 0. So 0 plus h minus f of a, that is f of 0 divided by h. Okay, okay, don't forget to write a limit. Okay, limit h tends to 0, that is equal to, see our function is f of x is equal to sin x. So what is f of 0 plus h? F of 0 plus h, that is sin 0 plus h, right? So here what is f of 0? F of 0 means f of 0 is sin 0, sin 0 is 0, right? Okay, now let us write limit h tends to 0, f of 0 plus h is sin 0 plus h, that is sin h, right? So sin h, here minus f of 0 is 0 divided by h, that is equal to limit h tends to 0, sin h divided by h. See what is it? What is its value? In limits we learned that that is standard limit, that is limit x tends to 0, sin x by x is equal to 1. Okay, so here the same thing, limit h tends to 0, sin h by h, that is equal to 1. So its derivative is 1, that is derivative of sin x at x is equal to 0 is 1. See the next question. Find the derivative of f of x is equal to x square. See here we have to just find the derivative of f of x is equal to x square. That point, a particular point is not given. Okay. To finding f of the derivative of f of x means f dash of x. Okay. Or we can write df by dx. See, if f of x is equal to x square, it is represented as df by dx, f dash of x or df by dx. If y is equal to x square, sometimes see in 12th standard you will find the derivative or differentiation of some functions using some standard formulas. Okay, so here we will apply the definition, right? So that is called the first principle method. So in 11th standard you will find the derivative of any function using this first principle method. But in 12th standard you have to apply that standard formulas. Okay. So here it will be in this form, that is y is equal to x square or y is equal to sin x. Okay. So in that form you have to find the derivative of this sin x, that is represented as dy by dx. Okay, or d, if it is f of x is equal to, then df by dx, or you can write f dash of x. Okay, okay, now we will find the f dash of x using our definition, that is limit h tends to 0. Okay, f of x plus h. Okay, here I did not take delta x or h, you can write whatever. Okay, limit h tends to 0, I have taken h. So that small quantity is h, okay. F of x plus h minus f of x divided by here h. Okay, our function is f of x, that is equal to x square. So what is f of x plus h? F of x is equal to x square. So what is f of x? F of x plus h whole square, right? So limit h tends to 0, x plus h whole square minus f of x is x square divided by h. That is equal to, let us expand this expression. Let limit h tends to 0, x square plus 2xh plus h square minus x square divided by h. That is equal to limit h tends to 0. See here, x square minus x square cancelled. Okay, then h will be cancelled, right? See, in both terms h is common. So we can take it out and cancel here. Okay, so remaining 2x plus h, right? In this term h is cancelled. One h is cancelled from this h square. So remaining 2x plus h. So here we can write it as limit h tends to 0, 2x plus limit h tends to 0, h. Okay, so that is equal to, here no h, right? So no h term, so its limit is 2x itself. Okay, so 2x plus, here limit h tends to 0, h means just to substitute, direct substitution method, that is put h is equal to 0, what you will get 0 itself. So 2x plus 0, that is equal to 2x. Okay, so here we have got derivative of x square is equal to 2x. See this question, find the derivative of x raised to n for any positive integer n. Very important. See, here given function is f of x, that is equal to x raised to n. Okay, we have to find the derivative of x raised to n. So let us write f dash of x, that is equal to, what is our definition? Limit h tends to 0, h tends to 0, f of x plus h minus f of x divided by h. Okay, here it is not given at any point, that is at a particular point, that not given. So here we have to find the derivative of this function x raised to n. Okay, so it is the definition, f of x plus h minus f of x divided by h. Okay, here what is f of x is x raised to n, right? So what is f of x plus h? So f of x plus h is nothing but x plus h whole raised to n, right? That is equal to limit h tends to 0, x plus h whole raised to n minus x raised to n divided by h. Okay, now let us write this expansion of x plus h whole raised to n using binomial theorem. Okay, by binomial theorem, let us write what is x plus h whole raised to n. We know that that is NC0, we have already studied, right, in binomial theorem, that is x plus h whole raised to n is NC0 x raised to n plus NC1 x raised to n minus 1 into h plus NC2 x raised to n minus 2 into h square plus etc. plus NCN h raised to n. Okay, NCN h raised to n. Okay, now here the first term is x raised to n, right? So let us take it left side. So it will become x plus h whole raised to n minus x raised to n. We know that NC0 is 1. So it is x raised to n. So let us take, we have taken x raised to n left side. So x plus h whole raised to n minus x raised to n. See here, in remaining all the terms have h is common, right? So h is common in remaining all the terms, right? See, from here to end, or h is common. So let us take it outside. So h into here NC1 x raised to n minus 1 plus NC2 x raised to n minus 2 plus etc. plus NCN h raised to n minus 1. Okay, h raised to n minus 1. So here x raised to n minus 1, h is okay cancelled. Here h is there, right? Okay, 1 h is taken outside, divided by, okay, now let us substitute this one here, okay, in our limit. That is f dash of x is equal to limit h tends to 0, okay, x plus h whole raised to n minus x raised to n is nothing but this one, okay, that is h into nc1 x raised to n minus 1 plus nc2 x raised to n minus 2 h plus etc. plus ncn h raised to n minus 1 divided by h, right? So here this h is cancelled. Next, see, let us substitute h is equal to 0 in this here. That is a direct substitution method. Put h is equal to 0. See what we will get. We know that, see, from the terms from here to end, every terms h is there, right? So h is common in all the terms from here to end. So when we substitute h is equal to 0, see, these terms will be 0, become 0, right? So only remaining this term, that is limit, okay, we have applied the limit. After applying the limit, we will get nc1, that is nc1 x raised to n minus 1, that is nc1 is nothing but n itself, right? So n x raised to n minus 1, okay, understood, right? See, we have to how to apply the limit. See, put h is equal to 0 here. So in first term no h is there, okay, so limit of this one is this one itself, that is nc1 x raised to n minus 1. Next here, see, in all the terms from here to end term h is common, that is h term is there. See, when we substitute h is equal to 0, all the terms will become 0, right? So remaining nc1 x raised to n minus 1. So that is nc1 is nothing but n. So n x raised to n minus 1. So remember here the derivative of x raised to n when n is any positive integer, that is equal to n x raised to n minus 1. See, in this case, see, after that, if you are asked to find the derivative of x raised to 7, okay, for example, derivative of x raised to 7. See, directly you can write the derivative of x raised to 7 is 7 x raised to 6, that is 7 minus 1. Okay, suppose if you are asked to find the derivative of one function using first principle method, you should apply this formula, that is by definition only you have to find, okay. Otherwise you can write directly, that is if you are asked to find the derivative of x raised to 8, then you will write 8x raised to 7, that is n into x raised, you have to apply this formula, that is n into x raised to n minus 1, okay. So 8 into x raised to n minus 1, that is 8 minus 1, 7. So 8x raised to 7, like that. See the next question. Find the derivative of 99x at x is equal to 100. See, it is not given. Find the derivative of given function from first principle. So you can directly, you can write the answer. That is, see, one more thing. See, f dash of ax, okay, suppose a is a constant, then that time you can take a outside, a into f dash of x, okay. So like that, here we will find, that is, here f of x is equal to 99x. So what is f dash of x? So 99 into d by dx of x. That is, we know that d by dx of x raised to n, or derivative f dash of x, that means, see, we can represent it as d by dx, okay. So d by dx of x raised to n is d by dx of x raised to n is n into x raised to n minus 1, just before we proved it, right? So n into x raised to n minus 1. See here, d by dx of x is nothing but, see, x raised to 1, right? So here it is x raised to 1. So n is equal to 1, okay, into x raised to 1 minus 1, that is 0. That is 1 into, that is equal to 1 into x raised to 0, that is 1. Okay, so 99 into, so we will write, say this constant, write as it is, okay, 99 into derivative of x is nothing but 1, okay. Why? Because, See, d by dx of x. See here, power is 1, right? That means n is equal to 1. So 1 into x raised to n minus 1, right? So 1 minus 1, that is 1 into x raised to 0, that is 1 into x raised to 0 is 1, that is 1. So remember, d by dx of x is 1, okay? Therefore 99 into 1, that is 99. So here it is given a derivative of f of x, that is 99 into x at x is equal to 0. That is, see here no variable, right? So it's a constant. So at x is equal to 100. So the derivative is 99 itself. Next question is, find the derivative of f of x is equal to x minus 1 into x minus 2 from first principle. Okay, see here we are asked to find the derivative of given function from first principle. So we should apply that definition of the derivative. Okay, so given function is f of x is equal to x minus 1 into x minus 2. First of all, let us expand it. That is x square minus 1 minus 2 minus 3 minus 3x plus 3. Sorry, plus 2. Okay, minus 1 into minus 2 plus 2. Okay. Now, what is our f dash of x? Derivative of f of x. F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, right? So here first let us find f of x plus h. F of x plus h is equal to, see, in place of x you should put x plus h, right? So x plus h minus 1 into x plus h minus 2, that is equal to, let us multiply 1 by 1, expand this, x square plus x into h, xh, here x into minus 2 minus 2x, okay, then h into x plus hx, then h into h, h square minus, sorry, h into h, h square, next x, h into minus 2 minus 2h, then minus x, minus 1 into x, minus 1 into h, minus 1 into minus 2 plus 2. That is equal to, see here, x square plus h square, xh plus xh, that is minus, okay, that is 2hx, okay. Next is minus 2x minus x minus 3x. Here minus 2h minus h minus 3h and plus 2 minus h, okay, minus 3h plus 2. Override. Okay. Next let us substitute it in our this equation, that is f dash of x is equal to here limit h tends to 0. What is f of x plus h? This x square plus h square plus 2hx minus 3h plus 2 minus, see, f of x minus of f of x, that is minus of this expression. So here let us multiply minus to each terms of this, that is minus x square plus 3x minus 2 divided by h. Okay. So here some terms will be cancelled, x square minus x square cancelled, minus 3x plus 3x cancelled, and next, okay, plus 2 minus 2 cancelled. So remaining limit h tends to 0, h square plus 2hx minus 3h divided by h. See, in all the three terms h is common, so let us take it out. So after taking limit h tends to 0, h into h plus 2x minus 3 divided by h, this h cancelled, so limit h tends to 0, h plus 2x minus 3. See here, by the algebra of limits, we can split it, right? That is limit h tends to 0 h plus limit h tends to 0 2x minus limit h tends to 0 3. Limit h tends to 0 h, that is nothing but 0 itself. Why? Because put h is equal to 0 by direct substitution method. Put h is equal to 0, you will get 0. So after that, limit h tends to 0 to x. See, that is 2x itself, no h terms, so 2x itself, and limit h tends to 0 minus 3, that is minus 3 itself. So the answer will be 2x minus 3. So 2x minus 3 is the derivative of this function. Say, suppose if you are asked to find the derivative of this function, okay, suppose if it is not mentioned from first principle, directly you can find this derivative. That is, first you expand it, that is x square minus 3x plus 2. After that, find one by one. Derivative of this, derivative of this, derivative of this. So derivative of a constant is nothing but that is 0. Okay, that you will study. So here we have found derivative of given function from first principle. So derivative of x minus 1 into x minus 2 is 2x minus 3.